So this video is about to share the order of convergence of Newton method. So before that we have already done fixed point iteration method, but we have done in the fixed point iteration method. Then when we have f of x equal to 0, we can transform this function in such a way that it becomes x is equal to gx, right? So for that we have done one remark, and we have also shown that the order of convergence of fixed point iteration method is 1. We have also done one remark that if your g dash, if alpha is any root, obviously if alpha is the root, or you can say fixed point, right? And obviously then g of alpha either will be becomes alpha, and you are saying that g dash alpha is also 0, g double dash alpha is also 0, and g pth my p minus 1th derivative is also 0, and the g pth derivative is non-zero, then we have done that in that case the order of convergence is p, right? So that we have done in the remark with the fixed point. So the same that this concept we will use in our order of convergence of Newton's method. So here we are going to show to find the order of convergence of Newton's method. So if you remember the formula, so we have given f of x is equal to 0, and we want to find the root, that is your x star, you can say. So the formula here is your become x n plus 1 is equal to x n minus function's value at x n divided it by f dash x n. So how we will proceed? We will proceed in the same way. We will proceed as in fixed point method. So what is your fixed point method? So that you can take x n plus 1. I can consider this as g of xn, right? So that my formula becomes that your xn plus 1 is equal to g of xn, where your gxn is xn minus functions xn and f dash xn, right? So the order of now we have already done. Now this is my gxn. So this I can regard as that my g of x is nothing but x minus f of x, f dash x. So we can remember the order of convergence, the remark for your order of convergence of your fixed point, that if I show that my g dash x is coming out to be 0, then and your g double dash x is not equal to 0, right? So here the order of convergence in this case will be, the order of convergence in this case is it will be 2. And similarly, if I'll go on, if I'll show that second derivative is also 0, third derivative is also 0, and then we can have fourth derivative which is coming out to be non-zero, then in that case my order of convergence is becoming your 4, because your fourth derivative. So till now we have to go, because for the simple roots we are finding, so the order of convergence Newton's method is at least 2. So it has order of convergence is at least 2 in case of simple roots. Simple root means when there is no multiple root, that there is no multiplicity, that is a simple root, then we use this formula. So now since we have gx is equal to x minus f of x divided by f dash x, if I'll show that g dash x is coming out to be 0 and g double dash x is not coming out, is coming out to be non-zero, then I am done that the order of convergence is 2. So we will start. Then when I want to find g dash x, so the derivative of x is 1, right? This is u upon v formula. So here v square, v as it is, derivative of u, that is your f dash x, minus u into derivative of v. U as it is, the derivative of v, that is f dash x. So its derivative will be f double dash x. So it is coming out to be 1 minus f dash x whole square minus f of x, f double dash x, and divided it by your f dash x whole square. So if you solve this, it will go up, and this f dash x whole square will be cancelled out. This minus will take this consider as plus. So this formula will become, this is f dash x square minus f dash x whole square plus, because it is minus it out from this, so it will become f of x, f double dash x divided it by f dash x whole square. So this term will be cancelled out. So you are left with term f of x, f double dash x, and divided it by f dash x whole square. This is f dash x whole square. So now you know you have given that alpha is the root. So what will be your g alpha? G dash alpha becomes in this case. So g dash alpha, if I'll this here, it will be f of alpha, f double dash alpha, and f dash alpha whole square. Now since alpha is the root of f of x, that means it satisfies the equation f of alpha equal to 0. That means my this quantity is becoming 0. So 0 multiplied divided it by any number, it will give you 0. That means the first derivative has come out to be 0. So that you have done already in this fixed point. If the first derivative is coming out to be 0, then the order of convergence is more than 1. So here, from here we got the idea that the order, obviously the order of convergence is, therefore the order of convergence is more than 1. Now how to show it is converging quadratically? So you have to go for double derivative. So if you take its double derivative, now my g dash x is coming out to be f of x, f double dash x divided it by f dash x whole square, right? So since I have to find double derivative, g double dash x, so I can consider this as my one function, right? This as my second function. So I'm naming this, suppose I'm naming this as f1. This is my second function f2, and this I'm suppose naming as my, this is not, since it is in the denominator, so what you can regard this, you can take this into 1, right? And then this you can take regard as the third function, right? Since you have UVW, so you can find its derivative. So if I am taking, the first will remain as it is, second will remain as it is, f1x, or you can take, so your f1 will remain as it is, f2 will remain as it is, you will take the derivative of this f3 dash. So in this case, f1 remain as it is, you take the derivative of second f3 as it is, then you can take f1 derivative, f2 and f3 as it is. So if you take f1, this is coming out to be f of x, f2, that is your f double dash x, f3 I am not writing its derivative, I am just writing with the prime, so that is 1 upon, because I need not to calculate this, because this ultimately I will show you how it becomes. This I am saying this is my derivative, this I am denoting it by derivative. So here f of x, again f2x, you can also take its derivative, it's becoming triple dash x, right? And this f3 as it is, 1 upon f dash x whole square, plus this is first derivative, this is f dash x, again f double dash x, and the third function as it is, right? So f dash x whole square, this as it is. So this is f dash x whole square, right? So now, since we have to calculate at dg double dash alpha, and alpha is the root, so if I'll calculate g double dash alpha, so g double dash alpha, if you say here, if I'll put f of alpha And what is my f of alpha? Alpha is the root. So this will become automatically 0. 0 multiplied by any term, right? So this automatically will become 0, right? Because if I'll put alpha over here, f of alpha is 0, right? F of alpha will be my 0. So it will become 0. Similarly, with the second quantity also, if I'll take alpha here also, here I'll take x is equal to alpha, then it will become f of alpha, which is my 0. That means my this quantity is also 0. Plus this quantity, f dash x1, you can cancel out. So here you will have f double dash x divided it by f dash x. So we do not know about the derivative is coming out to be 0, non-zero, and anything we don't know. So that will become, so here, this is not equal to 0 since we do not know the nature of f. So this is not equal to 0. Therefore, the order of convergence of Newton's method is at least quadratic. Or is, you can say, sometimes we skip this word, we show that the convergence is quadratic, because your second derivative comes out to be non-zero, and if it comes out in your exam, so you have to prove that part also. When I have considered that your g dash I, and when I have taken that first derivative is coming out to be 0, second, that remark which I have already explained, that you have to prove, right? So next, this is the order of convergence. So next, the order of convergence. So next, you have to show that the order of convergence of modified Newton's method, right? So modified Newton method means the order of convergence, or you can say the order of convergence for multiple roots, right? So you can see we have done so many examples that when we have multiple roots, if I'll consider only the formula xn plus 1, xn minus, that for simple roots, your formula becomes xn plus 1 xn minus f of xn divided it by f dash xn, right? So this was the formula that when we have multiple roots, the convergence in that case will become slow. That you can also check that I am considering this as function g of x, that is my x minus f of x upon f dash x. So why your convergence is slow, that you can also verify from this thing. However, we have done the convergence of uh, Newton's method is 2, but the why the convergence is slow for multiple roots here. So you can check here your obviously g alpha is when you will check, it becomes 0 upon 0 form. So when you know if it has multiple root, you can check my previous video also. If the function has a multiple roots, so f of x at alpha will also be 0. F dash at alpha will also be 0. F double dash alpha will also be 0. If it has multiplicity 3, then the third derivative will not be 0, right? So that means f of alpha will be 0, f dash alpha will be 0, then this will become 0 upon 0 form. So you have seen that whenever I have a function f of x equal to 0, and if I have a multiple roots, I can write like this: xi minus alpha m is equal to this, right? That means I have reduced the function x minus alpha. For example, that if a function has like this x minus 2 whole square x minus 1, so that means here 2 has one multiplicity 2. So here the 2 has multiplicity 2, so that you can write as x minus 2, that is my m, this is my alpha, and this is my nothing but this is my function phi of x, in which the multiplicity is simple or that you cannot reduce. So for escaping from 0 upon 0 form like this, I can write this function g of x is equal to, this is x minus alpha raised to the power m phi of x, because alpha has multiple roots with multiplicity m, right? So that I can write. Now in the denominator I have to write its derivative. So this is product rule. So here the derivative will be mx minus alpha m minus 1 phi dash x as it is, plus then x minus alpha raised to the power m as it is, the derivative of phi, that will be phi dash x, right? So I can write this, I can take x minus alpha m minus 1 common from this. So I will left with m phi of x plus x minus alpha. This is the quantity this, and x minus alpha m phi of x. So I can cancel out this. So I will left with this is x minus alpha phi of x divided it by m plus x minus alpha phi dash x. So because since you have shown that we are also going in this way, if I'll take its derivative g dash x, the same way I am calculating its derivative, I am considering this as one function, I am considering this as second function, and I am considering 1 upon into this as third function, right? So the derivative in this case will become 1 minus, because the derivative of x is 1. So x minus alpha as it is, right? P of x as it is. I am taking the derivative of third. I am just writing is third dash x plus x minus alpha as it is. Second, I am taking the derivative, that will be phi dash x. Third as it is, plus the derivative of first will be x minus alpha will be 1, and it will be phi of x into 1 upon the third derivative m phi of x plus x minus alpha phi of x. So here, if I put g dash alpha, because we have to check the g dash alpha is coming out to be 0. If it is coming out to be 0, that means the convergence is quadratic, right? More, at least more than 1. So here, if you put alpha x equal to alpha, this term will become 0 and the whole term will become 0. So this will be 0 plus here also if you put alpha, this alpha minus alpha 0, so the whole term will become 0. So here if you put x is equal to alpha, this term will become 0. 0 into anything, that will be 0, and phi here phi alpha, and this will be cancel out with each other. So I'm left with here 1 by m. Here it is bracket outside. So I am left with 1 minus 1 by m. Since m is not equal to 1, because we have multiplicity more than 1, that's why this is not coming out to be 0. Therefore, the convergence is linear for simple Newton methods. That's why it will converge to the root, but it will converge slow to the root. That's why we have modified the formula, so that we have taken xn plus 1 is equal to xn minus m times f of xn divide by f dash xn, and m is the multiplicity of the root, so that my gx in this case becomes x minus m. Here here I can write x minus alpha raised to the power m phi of x, that we have already done. So this is m times x minus alpha m minus 1, right? Phi of x plus x minus alpha as it is. This is my phi dash x, right? So this will become x minus m that you have already taken. So it will become x minus alpha phi of x plus m phi x plus x minus alpha. Here also might be I have written phi dash x. So the same, if you take its derivative, the same that in the previously I have taken the derivative that 1 minus m times, right? So this we consider as first function. This we consider as second function. This we consider as third function, right? So when you will take its derivative, so it will become x minus alpha, right? Px third derivative of third function plus x minus alpha as it is. The derivative of second, third as it is, plus first as it is, second as it is. The derivative of third, it will be this phi dash x, right? So this term, if you check, now if you go for 1 minus, if you put g dash alpha, so this will be 1 minus m, this quantity will become 0. So the whole term will become 0. This quantity will also become 0. And the same phi x will be cancel out when we will take this is equal to alpha. So when I take this alpha, and this term will become 0. So this will be cancel out. So I am left with 1 by m. So here, this has become 1 minus m by into 1 by m. So the first derivative has come out to be your 0. That means if you will use modified Newton's method, then the convergence will be more than 1. So if you want to check, you can go for the second. Therefore, the convergence is at least quadratic when we use modified Newton's method for multiple roots. For your multiple roots, right? So that you can check for your double derivative, you can check double dash x. So that depends. If you have shown that the first derivative is coming out to be 0, but if it comes in your exam, that you have to prove that remark that I have already shown in my previous videos, that when your fixed point has convergence more than 1. So just for this process, that this is your simple method. Therefore, in case of multiple method, if you apply this method, your convergence is slow, right? So that's why you modify your method for your multiple roots. If you want to check exactly the theorem for your Newton method, that what is exactly theorem, how we are considering this as function gx, how it is satisfying the property of fixed point, then you can check the next video, that gx should also belong to the same interval, and your g dash x in this, when you take this function x minus f of x divided it by f dash x, that comes out to be less than 1, that you can check in the next video. Okay, thank you.